Today we're going to talk about the how to prove triangles congruent with using less information than what we saw in our previous section 4.2. Recall in our previous section we showed figures congruent when we showed that every single corresponding part was congruent and every corresponding angle, internally at least, was congruent as well. So for figures in general, there's a lot of work. There's at least, for quadrilaterals or four-sided figures, there's at least 8 things you have to show. 4 pairs of sides, 4 pairs of angles. For triangles, we're going to actually see that there's some shortcuts, and we don't need to be able to discuss all 6 to show the congruent effect. We're going to find over the next handful of lessons here, we're going to see 5 actually, I guess, shortcuts, or like groups of information that if we have, then we know the entire triangle is congruent. And the first one we're going to start with is called the side-side-side postulate. It says just this, that for a pair of triangles, if all 3 pairs of corresponding sides are congruent, then the triangles are congruent themselves. So what this allows us to do is that if we can show that the three pairs of corresponding sides are congruent, then what this is going to allow us to do down the line is then kind of the next step is that then the corresponding, since the triangles themselves are congruent, if the triangle is congruent, that means that all the individual parts, so then all the corresponding angles automatically are congruent. And that's kind of like the next step, the down the line, what we're going to use this for. So today we're going to show how to do that, and how to, the big focus is going to be how to structure an argument or a proof as to why this is true. So by looking at these two examples, there's 2 kind of relatively basic examples here to decide whether the congruent statements are true and why. So is RST, triangle RST, congruent to triangle RQT? In fact, yes, it is. Why is it true? Because all corresponding side pairs are congruent. We just shorten that with the side-side-side postulate. In the second case, ABC congruent to DEF. Again, yes, by side-side-side. Now, if you wrote this congruent statement maybe a different way, maybe instead you wrote triangle ABC. Is triangle ABC congruent to triangle DFE? Well, no. This congruent statement is false. Because A and D may correspond. A is between the 3 and the 1 hash, and D is between the 3 and the 1 hash, but B is between 3 and 2, F is between 2 and 1. This congruent statement is not true. So we got to make sure we're careful about what the congruent statement is actually saying. The original one is good. If it were reworded, even though the 2 diagrams look alike, the congruent statement itself is important as well. Okay, so let's look at how we can use this idea to actually explain why some triangles are congruent. That's kind of where we're going to go for the rest of this lesson here. So we're given in this diagram that segment HI is congruent to segment HK, and segment IJ is congruent to segment KJ. Explain or prove why the 2 triangles are congruent. And for this exercise, I'm going to use a proof map. I find that for triangle proofs, proof maps or flow proofs, as the book refers to them, is a great idea. It's a lot better and easier way to organize your thoughts than in a two-column proof. And when I use a proof map, I tend to work backwards, and you'll see it'll become a lot clearer in the coming lessons when we have more than one explanation for why the triangles are congruent. But for now, we'll get the basic refresher memory on how to do so. So when I'm drawing a proof map, recall that's kind of our flow chart. So it was like a web diagram. So in fact, since I'm going to work backwards, I'm going to start with HIJ is congruent to triangle, HKJ. Remember that's a bubble, and then around the outside, I'm going to write my reason for why this is true. And right now, I only have one possible reason. I have side congruence. Why I'm doing this is, since I know that I have side congruence, that means that in order for me to claim this, I need to show that there's 1, 2, 3 pairs of sides that are all congruent. And each of these, I'm going to explain why a different pair of sides in this diagram are congruent. Once I know that, then those 3 things will come together and tell me by side that the triangles themselves are congruent. So I'm going to find a couple pairs of sides. And the first ones I think are the obvious ones, the given ones. So I know from the diagram that segment HI is congruent to segment HK, and that's given to me. I know also that segment IJ is congruent to segment KJ. That's given. And my third side from the diagram, so I have IJ and KJ, and HK and HI. The only one left is the shared side. So between the two triangles, I know that HJ is congruent to segment HJ. Why is something congruent to itself? Well, if you remember from way back when, it was one of those properties of algebra that we didn't use a lot way back when, but it's coming up a lot now when we have talked about congruence. It's called the reflexive property. And my diagram now shows, reading top to bottom, that I have 3 now individual pairs of sides that are 3 congruent sides. Those things come together from side to show that the triangles are congruent. So how am I going to write that up as an actual proof? Well, I might start with the following. We're given that segment HI congruent to segment KH or HK, and that IJ is congruent to KJ. Also, HJ is congruent to HJ by the reflexive property. Therefore, note the symbol for therefore, since these 2 triangles have 3 pairs of congruent corresponding sides, they are congruent themselves by side. The by side might be a little redundant, but it's nice to say that I know what the name of the theorem is, and I know why I'm allowed to apply the theorem, because I have 3 pairs of congruent sides. Example 2 on the second page of the notes is a different diagram, but very, very similar. Very, very similar to the first proof. In fact, the proof itself is going to look almost identical. It's going to look very, very, very similar. Okay, note that I'm trying to show that triangle ABC is congruent to triangle CDA. The only possible theorem I have is side, side, side. So I need to be able to explain why I have 3 pairs of congruent sides. Well, it seemed to have 1 pair, I have 2 pairs. And again, I have a shared side. So I have a congruent third pair here. I'll draw a little squiggly line through them to know that that's a shared side. So my proof map is going to look very similar. And that BC is congruent to AD. So it's given. I know that AB is congruent to CD, also given. And also AC is congruent to AC because of the reflexive property. So my proof be in the same vein. So BC is congruent to AD, and AB is congruent to CD. Also, AC is congruent to AC by the reflexive property. Therefore, since the 2 triangles share 3 pairs of congruent sides, they must be by side, side, side. So we'll look at one final proof. This one will be slightly different, and then we're going to have to do a little bit of work to explain why. I would do a little bit more work to explain like one of the pairs. So in this case, I'll go ahead and I'm going to tell you that one of the pairs of sides are congruent. And this time I'm going to tell you that Z is the midpoint. Okay, and again, I'm trying to explain why triangle XWZ is congruent to triangle XYZ. And the only possible reason I have is side, side, side. So I know when I'm looking, I know I have to find 3 sides that are congruent. One of them, the easy one, just told me XW is congruent to XY. That's given. The other piece of given information is that Z is the midpoint. WY. Then that's given. Well, what does it mean for Z to be the midpoint? Well, since it's the midpoint, that should mean that segment WZ is congruent to segment ZY. Why is that? Well, that's what a midpoint is. A midpoint is in the middle. So since that's what it is, that's the definition of midpoint. The third side, sure as heck, looks like it's the shared side. And that is reflexive. Therefore, my proof, and I found that 1, 2, 3 pairs of sides are congruent. So my proof will look something like this. I'm going to kind of lay out my argument going up the top. I'll start with the givens. I know that given that XW is congruent to, shoot, I shouldn't circle that. Why? And also that Z is the midpoint of WY. And I'm even going to take and kind of check off the things that I get there that I talked about. So I make sure I talk about every single thing in my proof map. Okay, so let's finish this strand here. So I know that Z is the midpoint of WY. Since it's the midpoint, then WZ is to ZY. since. Since it is, you could say since Z, you could say by definition, this is, I think it's implied here, especially with your map here, especially with the map drawn out, we can tell exactly what you mean here. Finally, XZ is congruent to XZ by the reflexive property. Therefore, since triangles share 3 pairs of congruent corresponding sides, I'll lay out the same triangle XWZ into triangle XYZ, side, side, side. Okay. Note that the proof map really helped me in organizing my thoughts here. I worked down each strand in my argument that I laid out in my writing. I completed the first strand. I talked about the second strand, finished it, third strand, and finished off with my last statement. And again, I mentioned why at every case.